Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is Dr. Luis Zea. Luis is an aerospace engineer and gravitational microbiology scientist with over a decade of spaceflight systems and development experience. Earlier this year, he founded Jaguar Space, a bioastronautics and business consulting firm helping customers design and implement their strategies in space. He was an assistant research professor in Aerospace Engineering Sciences at the University of Colorado Boulder and a senior business development manager at Sierra Space. Luis is the co-author of Spring Nature's Handbook of Space Pharmaceuticals and served as the co-director of Guatemala's first satellite. Luis, welcome to the future of space.
Thank you for having me, Daniel. This is pretty exciting to be here.
Well, first of all, congratulations on Jaguar Space. I can't wait to hear more about it. But before we go there, could you share with us 3 words that for you captures the essence of space?
Awesome. Yeah. So there's so many words, right? The first one that comes to mind though is fuel. I think it's fuel for the mind. It's fuel for the innate adventurous and exploring human spirit. I see ourselves, regardless of where you are located on the globe, we're like living on an island surrounded by a beautiful. It's like I imagine like somebody on an island surrounded by like this aqua and blue ocean, but not knowing what's beyond or not knowing what's underneath the water, just not being able to even put a toe in the water. It's just in front of you. It surrounds you. So that is kind of a fuel to imagine things of what could be there, but also a fuel to innovate, to find ways of actually going on the water and under the water. So that's the first thing that comes to mind. I think the other one is horizon. It is that horizon that we cannot look on the other side of what's on the other side, right? So it's equivalent to that ocean that we cannot go into, and that has a lot of different approaches to me. So I'm originally from Guatemala, and in Guatemala, things have changed. But when I was there were basically no opportunities to be involved with space, and same as a lot of, I'm sure your listeners. I have space in my DNA. It's somewhere there encoded in some genes, and because of that, I always saw the opportunity to be working in space as a horizon. It was something that I could see was in the very far end, but I couldn't know what was on the other side. In my case, for example, that's why after learning English, I learned German. I would go and learn German before going to my undergrad classes, because if I couldn't come to the States, I would go to Germany, but I had to do space. And later I graduated from my undergrad. I still could not find a way of coming to the States. So I got a job that, I kid you not, as an engineer paid $6,000 a year. And this was one of the best positions around. And during my lunch breaks, I learned Portuguese. Because if I couldn't come to the States or go to Germany to do space, then I thought, well, Brazil's got a lot of space stuff. So that's it. So it was like that horizon that served as a fuel, in this case, a fuel for self-improvement. And I guess that takes me to the third and final word, opportunity. It's opportunity to improve ourselves as we strive to achieve these personal goals of being involved in something very specific related to space, but also an opportunity to improve life on Earth. When you think about how life has evolved on Earth, it is something that usually people in the engineering world or policy world don't think about biology in space, and those few folks who do not necessarily zoom out to see all the way to the beginning of life as we know it on planet Earth. So for 3.5 billion years that we have had life on Earth, things have changed a lot. Just imagine planet Earth, what it looked like 3 billion years ago and 2 billion years ago. And like you had volcanoes, the composition of the atmosphere was different, the pH and salinity of the oceans. All of these has been changing through time, but through the evolution of life on Earth, there has been one constant, and that's 1G. The gravitational pull has been equivalent through that period of time. And now that we as a species, we have the ability to go to space, bring cells, bring organisms, bring tissues to space with us, we can see things that you simply cannot see on Earth. And I say that not only what we say phenotypically, which is what you can see with your eyes under a microscope, for example, but also in molecular processes. We see things that you can't see here on Earth. And I got several examples that I could get into, including my PhD thesis that was performed in space. So that is going back to the word of opportunity. It gives us the opportunity to learn, to improve life on Earth. We do cancer research in space, and I can get into more detail about why we do that or what has been found in space that could help us improve life on Earth. So I see that as fuel to improve ourselves, to improve our planet, fuel for our mind, the horizon that it's innate in us that wants to know, we want to know what's on the other side, and opportunity.
It's amazing, and I can't wait to circle back to all the work that you're doing. I've said, I mean, I've written several papers, and the conclusion is always kind of similar. But one of them is, we're about to give life. It's one of its biggest gift ever, is to take it beyond. Right? If you were talking about the single cell or the how life started on Earth, why would it grow in complexity for billions of years, only to remain on a tiny speck in the big scheme of everything, right? From a perspective of life, and I don't want to say that life has a personality or is an entity by itself, but the force of life just wants to expand and continue. The universe is expanding. Life is, it's entropy. And now you have this single, the planet is this single cell in this organism of the universe. And that we know of, there's the first species in 3.6 billion years is about to take that and go beyond and continuing that expansion and that work and that evolution. So it's the human species is not a bad species. Life is messy by design. So, Luis.
Totally agree. I don't think anybody who would pose us as all bad or all good, I don't think either is right. It's a mix. And it's a mix that is, in my opinion, heavily sided on the good. There's a lot of good in us as a species, and I think that's super important that people understand we are a species. Like we speak about, races, and we find ways to differentiate ourselves from other groups of humans. In reality, it's the human race. And when you zoom out, you mentioned like you're not going as far as saying like life is like is an identity, like a being or something. I agree, but and when you zoom out, for it could be said that Earth is an organism. It's an organism that has all these different constituents that include humans, that includes the oceans, all these things, right? So it is a lot of things to think about, including when you speak to folks at NASA and different places about what is the definition of life. And life itself, it doesn't have a hard definition. There's different definitions, some requirements of that things need to have. For example, the ability to generate copies of itself and other things like that. But there's a lot of there yet to be thought about and analyzed.
Yeah, it's fascinating. Everything is connected in some ways. Everything has its role to play, and yes, Earth has it's a system where all the pieces are playing a part, and we play a part, right? The idea that we can live on this planet without having an impact is first of all impossible, and second, that's not how it should be. We have to take, right? We have to live and participate in the system, but we live out of reciprocity. We have to learn to give back and to understand that our desire to care for the environment does not come from a place of righteousness. It's not our duty to save things, but it's our responsibility to understand that we are a product of our environment. And if we disrespect and if we trash the environment, then ultimately we trash ourselves, we disrespect ourselves. So it's more, come from a place of humility and understanding rather than this place of righteousness. So, Luis, and I think that we've been touching a little bit, but I want to hear more about what understanding the space. I think pretty much everyone is aware of the science story of going to space, the technology story of going to space. Now there's the geopolitics of going to space, but beyond that, right? What would be the human story of going to space?
The human story of going to space, I think it's it's barely getting started. It's been very limited. If we could fast forward 100 years and look back at where we were from the beginning till 2024, we'd likely say it was very limited in terms of who was able to participate. All right, when you see going back to the word opportunity that I associate with spaces, it's also the opportunity to grow up from our rivalries and work together. So I think that the human story of going to space has been limited to those who have had the resources to go and explore, and as that exploration happens, and through investment, discoveries are made. Now, some of these discoveries can have benefits for us on Earth, and a lot of people who live on the space realm, they go for Thanksgiving dinner or something, and somebody's like, "Oh, you do space? That's a waste of money. We have all these problems on Earth." Yes, we do have a lot of problems on Earth, and yes, we need to address them. Should that be a Boolean equation where it's true or false for each variable? Is it like just one thing or the other? I don't think so. In fact, by nature of exploring space, we have found things that have brought benefit to Earth. And a lot of people in the space world usually say, "Oh, GPS and these things," which are true, but there's so much more in terms of benefits. And I was mentioning, for example, that we do cancer research in space. So for context, I worked on 25 payloads, experiments that have been performed in space. I started in a space shuttle, the rest on ISS and around the moon in different capacities as an engineer, developing the hardware, or as we call it implementation project manager, which is helping a science team design their experiment, and then so that the crew members in space can perform it and doing all the paperwork for NASA and all those things. But also on the science side, as principal investigator, the last one I had went around the moon. We flew 12,000 mutants of yeast. Same thing we used to make bread and beer. The reason is because over half of the genome of the genetic code in yeast is shared with Earth, with humans. Which is pretty mind-blowing because we definitely don't look like yeast, but from the scientific perspective, we call those model organisms because in a little bag, we can fly trillions and trillions of these cells, whereas if you try to do that with humans, you would need a very, very, very large spaceship. And then we can actually go look at changes in how the genes were expressing themselves, how the cells were behaving, etc. But the reason for which NASA and other space agencies and now even industries looking into doing this kind of research in space is because there are benefits for people on Earth, but also there's commercial opportunities. So in the case of cancer, I've been involved with 3 different cancer experiments in space, flew lung adenocarcinoma from a 26-year-old patient, and and some other cases have been prostate or breast cancer cells. The 2 main reasons for which we do cancers research in space are these. One is when you're in the lab and you're a biotech company, you have a molecule that looks promising, that it may in fact be able to kill some cancer cells, but at the same time you want to make sure that these molecules are not toxic to the healthy cells, right? That's one of the problems with chemotherapy, that people who are undergoing these therapies have bad side effects because these medicines are not only killing the cancer cells but also damaging healthy cells. So if you're a biotech company, you have a promising molecule, you want to test it on a target, on something that looks like a cancer tumor. The problem on Earth is that gravity sucks things down, and then when you're trying to grow these 3-dimensional structures of cells, it is very hard to go past a specific size. It is very tiny. In space, where you don't have that 1G pool, we can grow very large 3-dimensional structures that better resemble what happens in the human body. It has that morphology, that right shape. You have some cells on the core, on the outside, some cells on the surface, some in the center. So you can actually have a better target that can help you reduce your number of false negatives or false positives, which is when you try a molecule and then you do it in the lab with a little tumor-like thing that looks more like a bidimensional disk, then it can have a false negative saying, oh, it didn't work. But in reality, maybe it could have worked. You just had the wrong shape. And space allows us to have large three-dimensional structures of cancer cells and other things. And the second reason is about protein crystallization. So proteins, when they start forming, they start binding to one another in a specific orientation, and that's called a crystal. And then when you have a crystal, then you can put it under these specific machinery. So there's different ways of identifying this, but what you do is you understand the structure of that protein, and based on that, you can do assumptions of how it folds and unfolds. And that matters because most of the diseases that we have are related with proteins. Either there's a protein that is not doing its job in one of our cells, or the medicine itself is a protein that is going to go bind to it. But that binding, it's like putting two Lego pieces together. And it's not only as simple as two pieces of Lego together. It's like I have my 4-year-old daughter come and build this funky tower with little arms of Lego, and then my other daughter has to go make another funky piece of Lego piece that will match perfectly. And that, for you to make that perfect match, you need to understand the structure. And that's how these kind of medicines work. You make a protein that goes and bind with the target protein, the one that's causing the problem. And you can either tell it to stop doing whatever it is doing wrong, or you can tell it to do more of something else. So these are the kind of benefits that come from space. So I think that the human story of going to space includes that. It's not only for looking beyond the horizon. It's not just because it's fuel for our personal growth. It is fuel for innovation and bringing is capitalizing on that opportunity to make life better for all of us, regardless if we go out there or not.
When people often compare, try to justify the amount of money, right? Even if the amount of money is really small for space, there's so many things that we do that achieve nothing but just our entertainment or for pleasure. Like I did a post recently on LinkedIn comparing the level of investment in space compared to the entertainment industry or the sport industry, and those are they're not helping climate change. In fact, they're contributing to climate change, and yet no one is complaining about the amount of money that is spent over there. But and there was one of the things that was coming into my mind when you're talking about what can be done in space with these new opportunities. I remember reading about the actor Jeremy, I can't remember his last name, one of the Hawkeye Marvel actor who had been crashed over by the snowcat, and in his recovery there was one element that really captured my attention, and it was zero gravity physical therapy. And in that moment, I really saw a future where when you get into an accident, the possibility of you going in low orbit and doing zero gravity physical therapy to help your muscle, because obviously the resistance is less, or like going just up in low orbit just to get a treatment because in terms of maybe surgery or in terms of other treatment, the lack of gravity is helping certain procedures or certainly recovery. But it's, from what you work, I know that you work also, I believe, with Christopher Mason, correct?
Yeah, we've collaborated, absolutely.
So talk to us about some of the work that you're working on right now, beyond the cancel, the yeast, right, going around. And then before you tell me, the thing that ran through my mind when you're talking about yeast is I did this, I wrote about how, like, what brings life is not just the ingredients, because the yeast and the bread, and the analogy that I was saying is, often we look for the ingredients and we think, well, if the ingredients are there, then life must exist. But my perspective was that it's not necessarily the ingredients that you need to look for. You need to look for an environment that is constantly putting those ingredients in conflict, right? If you look at the for instance, bread, right? Bread, it's yeast, it's flour, and it's water. Well, you could have these ingredients on the counter for hundreds of years, thousands of years if you wanted to, but you will never have bread. What needs to happen for bread to happen is you need these ingredients to come in conflict with each other constantly. And then once you think that, and then you need a little period to settle so that it becomes more alive. And then once that is done, then you put it into the fire. So then now it creates something else. And I think that the magic of Earth is not just, it's the ingredients, but it's that magical place where with the moon, with the sun, it's all these ingredients are constantly mixing with each other that, you know, that allows life to thrive and to adapt. But that was just a little percent.
Yeah, no, I hear it. It's the ingredients, but also look for the ovens and other indicators that maybe there may be a kitchen there. And in fact, so astrobiology groups at NASA and other places are looking for both in different ways. So amino acids are the basic building blocks of proteins. There are amino acids out there. So finding an amino acid doesn't necessarily mean that it's associated with life, but it can be a proxy, an indicator, depending on what type of amino acid. If it's a left or right, there's different things that can be looked for, but also the ovens out there. So, for example, folks who are looking at the light that goes through the atmosphere of exoplanets, planets orbiting other stars, and they wait for the planet to be right in between that other star and us and see the light that goes through the atmosphere to try to understand the composition, because each element will absorb a different wavelength of that light. And then when it comes here, compared to the wavelengths of that star when the planet is not there, can tell us what is there. So I agree. Yeah, it's a matter of looking for both components. And when you were mentioning about sports and like how much money is spent on other things, like if you compare how much money goes on buying chewing gum versus doing biosciences or medical research in space, things like that, and yet people are not complaining about those other things. I think that's a call to action for us in the space community to better communicate that. As I mentioned, like if we go for a Thanksgiving dinner or something, usually we have the same old stories of benefits of space, and like GPS is always in front because it's obvious for people that they use it for everything on their phone. But there's so many other things, especially on the medical side. For example, so astronauts when they're in space, they have to work out every day. Otherwise, there's several things that happen to them. One of them is bone reabsorption. So there's this thing called hemostasis. So that's the body trying to maintain an equilibrium. So right now, if your listeners who may be sitting on a car or sitting somewhere may be thinking that they're not doing anything related to their bones, but in reality, just the fact that they're under 1G puts stress on that bones. And then that keeps your bones at certain mass. When you go to space, you don't have that stress on the bones anymore, especially on the lower limbs and the hips. So then the body, because of hemostasis, is like, wait a minute, why am I spending all these resources keeping all this bone mass if I'm not using it? So it starts reabsorbing it. It reabsorbs it in some bones at a rate that is over 10-fold worse than the worst type of untreated osteoporosis on Earth. So that is a problem for space exploration. But again, the third word about what I see space as is opportunity. That opportunity to test molecules that biotech companies think could be a drug against osteoporosis, now you can do accelerated modeling. In fact, NASA, Amgen, Bioserve, and others have flew cohorts of mice on space shuttle. Half of them were given a placebo, the other half were given this molecule that seemed promising against osteoporosis, and on Earth the same thing. They had the two groups. The mice that flew to space and had the molecule, they not only had more bone mass than the ones that flew to space and had the placebo, but they actually had more bone mass than the ones that stayed on Earth with the placebo. That molecule eventually became Prolia. It's a drug that even my mom now uses. She's got osteoporosis. It's now in the market, and it sells. The sales per year for Amgen is on the billions of dollars. They have likely had a return of investment pretty quick, because when you go, and this information is online, when you see how much they make out of Prolia, it's a lot. So that is benefit to people on Earth, and these are the kind of stories that we in the community need to be able to know and share with others. But in this case, it's not only benefit to people, but that is a commercial benefit. And if you can do better, if you can do good in the world, that's great. But if you can do good in the world in a way that's financially sustainable, and you don't have to wait for a billionaire to give you money, then you're golden because you're doing good, and you can continue doing good for a longer period of time.
That's incredible. What else are you can you share about these discoveries where or that you're working on, hoping that it becomes a discovery?
Well, now I've changed gears. So I went from an aerospace engineer to full scientist. My PhD is on bioastronautics, and then I went for business development. And now I went for entrepreneurship. I got my own bioastronautics consulting firm. It's called Jaguar Space, and there's different projects that I have under Jaguar. But there's so, because I said I worked on 25 different experiments that have gone to space. So there's a lot of, like, one of them, for example, is we flew sperm to space, and very few people know about this. In fact, when I was sitting with the principal investigator in different like press conferences and stuff from NASA, like usually that payload did not get much attention because it's controversial. So in that experiment called Micro 11, we flew sperm. There were no eggs present. It was a fertility study. Fertility study because we talk about from the technology side of when humans have the technology to become multi-generational in space. But guess what? We don't have enough data to demonstrate that in fact we physiologically can be a multi-generational species. Are we going to be able to go through the thousands of different steps and processes that is needed for humans to reproduce? In this specific experiment, it was just the sperm, as I said, there were no eggs. It was led by Dr. Joe Tash, a principal investigator from the University of Kansas, and this was implemented by BioSurf, where I was working at the time. And the intent was to understand whether there were changes in something called capacitation and another thing called motility, which itself is pretty obvious, of sperm as a result of microgravity. The manuscript doesn't work, but there are a couple of findings that have been already published in the American Society of Gravitational and Space Research, which I'm also on the board of directors. But that presentation was a few years ago, and this is very interesting. So we didn't see much changes in the motility of capacitation of the sperm in space with respect to Earth, except when the experiment was taking place as the International Space Station was flying through the South Atlantic anomaly. That's this gap around Brazil where there's a higher radiation dose as the ISS flies at about 400 kilometers altitude. So that infers that microgravity may not be that much a problem, specifically for those two parameters. Capacitation, which is the ability of the sperm to go and kind of melt the membrane of the egg so it can fuse to it. But also motility, its ability to actually swim towards it. It's chemotaxis. It's a gradient of a specific chemical that it sniffs, if you will, and that's how it knows where to go. So there's a lot of that. On the Jaguar side, the reason for which I incorporated Jaguar Space is to help. Here's what I think. Coming from Guatemala, having traveled a lot, after the PhD, my first gig was sponsored by the Brazilian Space Agency. I did part of my PhD in Germany in the Deutsches Zentrum für Luft- und Raumfahrt, which is DLR, or the NASA, German equivalent of NASA. And I know for a fact that there are great minds and great ideas all over the world. It doesn't matter where you were born. There are great ideas, great brains. And what I'm trying to do with Jaguar Space is give these brains and these ideas an opportunity to be implemented in space. Because not only can they help space exploration, but they can also help find these benefits that we have been talking about. But the other side is the folks who haven't had access also include pure commercial. That has been very, very hard, very difficult. So, for example, one of my customers right now is a brewery that we're going to be doing some official posts soon to look into the brewing process in space. So, as I mentioned, I flew yeast around the moon. I worked on yeast on the space station, and now it's trying to do so for a commercial purpose of making beer in space for use on Earth.
Well, where humans go, alcohol always follows. So I was just having a conversation with Octave who designed a champagne bottle for space, going up in on Axiom. So it was really, really interesting, the science of the design, the product design, right? How do you keep the ritual of something like champagne, where the champagne is not just the liquid, but it's the ritual of opening it, the sound, the smell. How do you transfer that, as we go to space? There's some.
That is exactly right. That is, and go back to your question of the human story of going to space. Now let's zoom out and say, what is the human story? What are these experiences, right? There's been good, there's been bad, and the story and the experiences include, in this case, for example, bread or beer. These are things that are as old as humans have been able to settle and stop being nomads. And like actually a couple of years ago, there was this really interesting archaeological finding in a city in Iraq that was populated. I think I can't remember now the details. It's got to be somewhere several thousand years ago, maybe between 2,000 and 4,000 years ago. But the fact that the archaeologists could pinpoint it was a brewery. Basically, there was a little table in the center. They could see artifacts that were used for making beer. There were still pieces of recipes. That's how they know what is it that they were brewing there. And they could see what they were using as currency. So that is part of the human story. That's coming with us. These things, like the things that we eat, right? And when you think of for example, when I think of Mediterranean food or Greek food, I think the cucumbers, tomatoes, right? If I think of German food, it's got like potatoes, and like potatoes, tomatoes, these things, they didn't exist there a couple of hundred years ago. See, these things came from Latin America, and or coffee, right? Coffee is like drank all over the world, but it's not a native plant from all over the world. So these are things like the human experience. As we go to space, we're going to bring these things because these are the things that make our day to day and living our lives, just more enjoyable.
It's always hard for people to grasp the achievement of the past because they take today for granted, right? And then they look into the future, and they look at space and they say, well, space is like a total different realm. You can't compare space to anything that we've had previously, and that's a really wrong way to look at it, right? You have to look at what represented the impossible back then and now is achieved today and not even questioned. And that is how, like, you have to look into the future. Yes, it's really challenging, but this is what we do. We're constantly having, we're trying to figure things out, where we have a lot of people working on these issues and challenges. And the thing that for me, like, makes me really optimistic is back in the days, not too long ago, and I think that you're a testament to that. Knowledge and opportunities were really limited to few circles, few individuals, right? If only a few people could go to school, knowledge was really kept within certain groups. But now as we have more people, and then we have more people opening, creating opportunities, knowledge and the capacity to do something with the knowledge is increasing, right? And I look forward to a future where there's going to be 9, 10, 15 billion people in, on Earth and outside, because even just a small portion of that 15 billion people that wakes up every single morning trying to find solution, just increasingly knowledge becomes more productive, as we move forward. So I think we're on the cusp of like having the understanding of what is the human experience to be radically changed, because that leap that is needed to for off the planet will just create an entire new field of opportunities, not only science, technology, but for people to feel that they don't have their place anymore on Earth. They feel like they're going to go and try somewhere else, just like what North America was, and that has been for so long.
Absolutely. Yeah. No. Yeah. I totally hear you on that. The access to opportunity has been limited in a lot of places, and I can speak more personally about Latin America.
Please.
Guatemala specific, Central America more, and Latin America more generic. So right now, and opportunities are so limited, right? But also, we gotta do something ourselves, right? If we see something that we don't agree with, that we think is wrong, that could be improved, it is upon us to go and fix it and not wait for somebody else, right? So I'll give you the example of space, access to space, or access to things related with space and the opportunities they bring, or the lack thereof, in Central and Latin America. So right now we're going to have the second Central American Space Congress. This year is going to be in Guatemala. The reason for which the organizing committee, we're six Central Americans who live in and outside Central America, from NASA, different places all over the world. We realize that lack of opportunity, and IAC, the International Astronautical Congress, is such a cool conference. It is the place where you can go meet people from all over the world and exchange ideas. And something I really love about IAC is like the 2001 Space Odyssey movie from Kubrick, and this is from a 1969 movie. There's this scene where an American and a Soviet scientist are meeting on a space station that's rotating around Earth, and they ask each other, "Hey, are you going to IAC this year?" "Oh yeah, I'm bringing your family. It'll be great to see your wife." That was in 1969. IAC is still ongoing. And then when the six of us met there, we were like, you know what? It is unfortunate that there's so little participation from Latin American. It's because most people can't afford to fly to Paris or to Azerbaijan or Sydney, where it is. And it would be great if we could have a local version of this, where students and entrepreneurs and government people can come over and have a similar kind of conversation. And that's why we started the Central American Space Congress. And now it's grown more than that, although it's still the second. The first year we were expecting something like 50 people. We did it in Costa Rica. We had no idea if there was an actual need in the market for this. Over 400 people attended from 19 countries in Latin America and Europe. The U.S. State Department asked us if they could come there. Of course, they were welcome. NASA centers, the Mexican Space Agency, Latin American and Caribbean Space Agency. And now it's grown. Like, this Congress is going to happen in September 10 through 12 in Guatemala City. And we already have confirmed people from different centers of NASA, from the Mexican Space Agency, Latin American and Caribbean Space Agency, the Portuguese Space Agency, the Egyptian Space Agency, the Japanese Space Agency, JAXA, the German Space Agency, DLR, the Costa Rican. This is growing so much, and now what we're trying to do is make it a one-stop shop for people who want to do business and find collaborations with the Latin American ecosystem to be able to do that in one single trip at one time. So that's kind of the example of taking action to go and address these challenges. In this case, the lack of opportunities in some geographical regions.
Now, incredible, absolutely incredible. Luis, did you always grow up looking up to the stars and say, "This is what I want to do, and I'm going to try to figure it out"? Or what is the journey behind?
Yes and no. I was a sponsored skateboarder when I was in high school. I flunked classes since I was in third grade until my junior year. I got expelled. I got kicked out from my high school because I was just such a bad student. It was just terrible. Skipping school, escaping from school. It was like, my poor mom. Now that I'm a dad, I'm like, oh, what did I do to my mom and dad? And really, space was that fuel for me to snap out of it, to realize that although I had I had never seen anybody from Guatemala or who looked like me or who had done something like me to be able to go to the States or somewhere else and do space stuff. I had no proof that it was possible. So that was discouraging. But I think that innate fuel and hunger for knowledge and for knowing what's out there, being part of that discovery process, is what allowed me to actually focus in school, become a good student, and then become a total nerd. Now I went for a master's and a PhD. Now, after a PhD, I was an assistant research professor at CU Boulder, working crazy hours, but still taking classes like astrophysics classes on what are the equations and what are the mathematical principles to identify exoplanets orbiting other stars, or molecular biology, things that, I don't know, I guess The message is that that capability is innate to all of us, and we each need to find what is that North Star, what is that thing that motivates us. And in fact, if we work for it and we work hard for it with a plan, anything can be achieved. And that goes to the personal as well as the community, the whole group.
So what was that tipping point? What was the that moment that brought like where space became not just like a concept or this this unrelated thing to becoming that focus? Was there like a moment that you can look back and say, okay, this is when I went from not interested in school whatsoever to now I understand where I have to go?
Yeah, I think there was when I decided to change the skateboard for books. Um, I don't know if your audience remembers, this is very long time ago. Back in the day, Discovery Channel actually showed science. And there was this science show where they're interviewing this person who is describing the spacecraft they were working on to go to Jupiter. And on the title said Aerospace Engineer. And I was like, what? You that's a thing? You can be an aerospace engineer, and their job it is to build spacecraft and do space stuff? That's when I said, you know what? Maybe I can. This is like the beginning of the internet. Not like the internet today. It would be like and like slow, like bad websites and trying to get information on how do you even do that, right? And of course, I had like the worst grades, so I couldn't find scholarships. My family couldn't afford to send me. So it took me 7 years from that moment until I was able to come to the States for grad school.
An amazing journey, Luis. Like truly, what an inspiration. Um, moving like from all this experience and what you've been working on and the things that you're looking for to accomplish. So connecting the past, the present, and the future. What would be 3 words of wisdom, Luis? 3 words of wisdom.
Well, let's assume you have a special going on today and you get 4 words at the price of three. So I'm gonna say we choose our future. We choose our future. It's not written. We build it through our actions. Our actions come from what we say, and what we say comes from what we think. And I'm talking about our personal and collective future. We decide what is tomorrow going to look like in terms of what's in our hands. We cannot decide how people if people are mean or bad things happen to us. That's outside our hands. What's in our hands is how we react to that. And if we plan as individuals and if we plan collectively, we can actually achieve those futures that are better. Um, I think that really that how that we build our collective future through building our personal one. How we behave, how we raise our children, uh, teaching them to be nice to other people, or we're gonna teach them to hate or judge others by X or Y reason. We choose these things by our actions, and they come from what we think.
That is often, I mean, what I want to bring people back to when they say human nature. We tend to portray human nature as the worst. The compared to nature, we think that nature is this perfect equilibrium where everything is hand in hand, and the ideology, the romanticism of nature, when in reality nature is really messy and doesn't care much about whether you live or whether you survive. It's just you have to adapt, and it's unfair, and that's what it is. But the human nature, it's the capacity to change things and to change the narrative and to reframe the future, and also a capacity to rise above the unfairness. Nature doesn't really care for the weaklings. Either you follow or you don't follow, but we do. We change the unfairness of life, and we want to give others an opportunity so that they so we support each other, and we look at what works and what doesn't work so that we can rewrite how we want to move into the future. So it's fabulous. It's the story of what you're working on and all the biology. I mean, we could spend hours just kind of listening to all the intricate experiments that you're working on and looking to change and right. But I think that the like right now, I think that the world is at the same place of around the 1900s, where you had Tesla, you had the Wright brothers, and you had Edison. The two were working at power the world, create a new reality, and then the other one was taking over the sky. And the same kind of criticism was happening back in those days. They thought that it was a waste of time to take over the sky or find a source of power when people were dying of other diseases. But the reality, the world that they created, allowed so many issues to be solved and elevated so many people, in the opportunity of doing something new. And that space is going to be part of creating that new world. So thank you for being part of it.
Thank you, Daniel, and thanks for having me here. It's been a pleasure to be here.
Wishing you good luck with Jaguar. I know that you just started it in 2024 or earlier this year, but I see no worry that this is going to be a successful endeavor from you. So good luck, and I think that there's more projects coming with Christopher Mason. Is that correct? Or
yeah, we actually just submitted a paper to Nature. It's based on it's the initial results of this experiment that I was telling you about, that I served as principal investigator for yeast around the moon. So yeah, it will be pretty interesting. Just first of several, hopefully.
Just out of curiosity, if you had the opportunity of going to the moon, would you?
I would need to make sure my daughters are grown, and when I travel, it just breaks my heart to leave them. So one of my intents coming to the United States was to be able to not only be part of that envelope pushing into space, but fly myself. Now I just miss them so much. Even if it's like a one night out, like I fly, like for example, I flew the day before yesterday out, came back yesterday, and even that is hard. So I would need to wait for them to be older. But if that has happened, absolutely yes, absolutely yeah. Not only for that experience, but actually go and do science there. Go and mature technologies. Be part from that side. There's different ways of serving that effort, and that would be pretty cool to do too.
Well, Luis, I wish you and your daughters and your family a wonderful July 4th celebration. This is July 3rd today. So by the time it comes out, it's going to be after. But thank you for taking the time. Inspiring story. I'm so glad. I think Kevin connected us. So thank you to our friend Kevin. And like I said, wishing you a wonderful July 4th celebration to you and your family.
Thank you. Likewise, Daniel, and to your whole audience.